tip on 10.3 because there was a subtle point that a lot of people missed. And I'll show you what that was. So there were a bunch of sets Sj, and we at some point in the proof you needed to have that the summation of n, as n goes to infinity, of the measure, outer measure of the union from j equals 1 to n of Sj, you needed this to be equal to that, which they're not the same thing necessarily because anyway. Well, and it turns out that you can get a less than or equal to using the order limit theorem, and you can get greater than or equal to using the definition and careful choices of intervals. So what do I mean by that? So for instance, since sum from j equals 1 to n of Sj is a subset of the sum from j equals 1 to infinity of Sj, then monotonicity implies that the outer measure of the first thing is less than or equal to the outer measure of the second thing, right? And then you can take the limit as n goes to infinity, right? Since you have a less than or equal to, it stays less than or equal to. So that's the first part. But then the second part is a little bit trickier, and you just have to use the fact that for all beta j greater than 0, I'm using a j because it depends on j, that you can find a collection of intervals. I'm going to put ajk such that Sj is inside the union over k of ijk, and the measure of Sj, well, it's less than that measure, but it's greater than or equal to the measure of this guy plus beta, or minus beta, sorry. Because that's kind of like the sup lemma and the nth lemma. You've got to be able to find a bunch of these that gets really close to that, since this is the nth of that. And then and I'll put beta j here, right? Because it depends on which j. And the idea is choose beta j such that the sum of beta j is epsilon. So in other words, put like 2 to the something in the denominator and add it up, and then actually where it adds up to epsilon. And then when that happens, you can show that the limit as n goes to infinity of m star of j equals 1 to n of Sj is actually greater than or equal to m star of the union j equals 1 to infinity of Sj. Yeah, the idea is you'll show that this is true minus an epsilon, and then you can, since it's independent of epsilon, then you can get rid of it. Anyway, so good luck with that. Just wanted to give you that tip. See you later.